Hi guys, welcome back to the last episode of SciCraft Season 1. So as we said, in preparation for our restart in a new area, we built this main storage so we can start right away without going to the pain of, well, having chest monsters everywhere and items not being sorted and so on. So yeah, the main storage has now been finally built up. The brewing system also has been fixed. It's working again. We still owe you an explanation how the bulk storage part interacts with the main storage slices. So Hoda here was kind enough to explain it all.
Okay. So now let's go to bulk storage. This is
Mm,
the complicated part, so I'm going to try to make it as simple
mm,
as possible.
Okay.
So the
So
bulk
first of
storage is
all, we should maybe explain the bulk storage, why we have it. So of course, we already have like a little bulk storage here. We can store about 100,000 of each item, but some of those we have even more. So what are we gonna do with those?
okay. So again, as Mango said before, the goal of this storage was to make it as less laggy as possible. And the problem with if we want to have a bulk storage in the storage, it will mean that we will have a lot of chests and a lot of hoppers for each slice. So currently the goal is to make 1 million per bulk slice.
Hmm.
And you can imagine that the amount of hoppers and the amount of, especially of chests, that will be loaded by the player. And we don't want that because we will be like it's already really laggy. I don't know how many FPS you have here, but yeah, it gets really bad if you go to where the bulk
Oh
is.
yeah, if we have
So
distant horizons, yeah, all of those chests add up, and yeah,
yeah,
having more would be really bad at this point.
so the solution is to have the bulk storage somewhere else, not here.
Hmm.
The problem with that is that it needs to be connected to the hull somehow. We cannot simply connect every single slice to the slice of the bulk because that will require it will be huge. Like the actual connection of the hull with the bulk will be bigger than the bulk itself. So what we do instead, if we code the hull. So this is an encoded bulk, and that's a scary word for technical Minecraft. But yeah, we managed to do it. So I guess we can quickly go to where bulk is so people can see how huge and how massive it will
Yep.
be if if it will be on top of the storage, right?
Yeah.
So
So I
yeah,
was
it's here.
building a lot of this, and at some point, with all the chests, the FPS for me got really bad.
So yeah,
Yeah. It
it
also
will
really
be
goes
really
down
bad.
here. There's just tons and tons and tons of chests and hoppers.
Yeah,
Definitely
so
not
this
something we want in the other area.
yeah. So how we do this? Okay. So I don't know if any of you have ever used how is this thing called in English? The machine where you get, for example, like Coca-Cola or
A
something like
vending
that, or
machine.
a vending machine. Yeah. So this is really similar to a vending machine. So how a vending machine works is that you normally input a number and you press a button, right? And you get what the order. For example, let's say like 107 is a Coca-Cola, right? So
Hmm.
you press 107, you press a button, and you get a Coca-Cola. So this is really similar to that. So what will happen is that you send a code, in this case, let's say 172, you press a button, and you get the number, or in this case, boxes, that is selected to 107. So if we go back to here, we can explain how quickly we can quickly explain how encoding works, let's say. So the normal word of encoding means that we are coding something. In this case, coding will be um, converting something into a code that later can be decoded into something that we want. In this case, we are coding the whole itself into a number. Then later we can decode that number uh, to select a slice.
Hmm.
So what will happen here is that
So
you can
is
see
this
this.
about the calling function now or the storage? Because you said there's a function, if like this little storage is empty, it would request more
Yeah.
boxes from the other one. So that's about that,
So,
right?
yeah.
Okay.
So right now we are starting about calling.
Okay.
So the system has sorting and calling.
Okay.
So as you can see, this thing here, this is, I guess we can quickly go here because it's going to be easier. So
Hmm.
this is white wool, right? And we are coding white wool into
Yep.
down here into a code. So if you know binary, you know that this is 00001,
Yep.
and that will mean this is number one. As you can see, this is the second one, so this is 10, that's 2, this is 11, that's 3, etc. So this is like a truth table. And that means that whenever we call from that hall, it will trigger this, and it will trigger this number. So again, imagine a vending machine, so it will be the number 1. So whatever is selected in the number 1. Then we use a serial transmitter, which is a way of sending binary code in a single rail line. So this is a serial transmitter. We can, again, convert the binary code into a single different serials, let's say, of input. So, for example, if we select different, let's say 10110, it will trigger 3 times. And different signals. So yeah, this is a concept that has been around for a long time, and we are using it here. So what will happen is that we send the signal, we follow the rail line. As you can see, it will just get sent to here, and we just goes upwards, right? It goes to this rail line up here. So this one is the one that goes to back.
Okay.
So imagine that we are sending again the number 1, right? I guess I can quickly show how it will work. So everything will get sent to here, and this is a binary decoder. So this is basically the same thing as a serial transmitter, but it converts the serial signal into an actual binary signal that we can use.
So taking a number of pulses and
Yep.
transfers it back into the code.
It's better to see it working because it's really hard to explain. Yeah. So this here is the decoder, right? This is what selects the actual slice. So I'm going to quickly send a code.
Okay.
Right. So this is kind of something that you don't want to happen to see, right? So I'm going to quickly change how this thing works. So, it doesn't do anything because else it will kind of break. So let me quickly wait. What is this? Yeah. So what I'm gonna do is I'm going to prevent the calling from working, so nothing gets called. All right. So I'm literally breaking the system right now, but just for good purpose. Okay. So what I'm gonna do?
Should I follow you or should I stay here to bulk?
Just stay there.
Okay.
What I'm doing right now is I'm purposely, like, let's say I'm just triggering the code, but I'm not gonna do anything with it. So yeah. If I do that normally, it will break because that's not something that you want to do. But since I know what I'm doing, I can do it. So I'm going to select the first slice of the first hole. So where you are right now, you can see that there are like 6 different holes. So I'm going to select the first slice of the first hole. I'm selecting it now. Let's see if it works.
Yep.
And there we go. And as you can see, it selected the first slice. So what we did is we converted binary into serial and then serial into binary again. And we selected the actual slice that again, it's just 0, 1. So actually 1. And yeah, that will select this slice. Now, since it's selected, selected means that all of the hoppers are unlocked, basically. So there is a dropper line on top that will up here. Okay. So this dropper line.
Yep.
Okay. So there is a dropper line here, right? That will get sorted. So as you can see, this hopper is unlocked, and then there is this dropper line that is locked. So the dropper line will just stop here, right? The items are going there. I will just get sent into the slicer. So that will be sorting. However, there is another part down here, right? And that's the calling. So we have another dropper line down here, and that's the one that we use to call.
Okay.
So if it's selected, that means that we can get items from here.
Mhm.
It's a bit more complicated than that, but yeah. Right now we
So,
selected.
how many sorry, how many items, how many shulker boxes will be sent over? Do we select it manually, or is it just if
Okay.
this one is empty, it's gonna send over a couple, or how does that work?
Okay. So in calling, we have two options. We have player call and whole call.
Mhm.
So that's selected by this system here. It's a really small system. So if you go and check and this dropper where I am right
Yep.
now, you can see that there are two items,
Yep.
right? So if we trigger this signal once,
Mhm.
the rest on that will just get sent into this dropper and it will trigger this comparator,
Mhm.
which basically what we'll do is we'll trigger this clock here. And this clock, if you check the dropper,
Mhm.
has 26 items. That means it's going to call an extra, so 27. So what will happen is that if there is one item, it will try to call for 27. So if the player, and that's the player, if the player calls, it will only call 27 boxes.
Mhm.
However, if the whole calls, it will trigger this thingy twice, this red line. It will
Mhm.
trigger twice, which means there are two rest on that now in this dropper. And that means it will reset twice. So that means it's going to do 27, and then like half a second later, another 27.
Mhm.
So it will call for 54. So basically a double chest.
Okay, so if it's empty, it calls for 54 shulker boxes.
Yeah.
Okay.
So I guess we can try to actually. So in order to send items, because we have not really explained how the calling works,
Okay,
we
coming
just
to you.
we okay. So what we explain basically is how bulk selects items.
Mhm.
However, we need to explain how it calls and how it sorts. So let's quickly explain how it sorts. So we have this thing here. This is an encoder,
Mhm.
and just imagine an encoder as normally when you send items or you want to sort items, you just filter items, right?
Mhm.
However, in order to use the filter items, you need to send items on top of filters. So imagine an encoder as a contrary thing. So what you do is you send a filter on top of the items. Okay,
Yep.
I think that's the easiest way to understand an encoder. So what will happen is that if you check this minecart, it has 4 shears and an empty slot, right?
Mhm.
So if we place an item in here, imagine glass,
Mhm.
this minecart will get sent into a piston mod and it will check every chest until it finds a glass. So you can see that the chests are full with different items.
Yep.
And for example, the second chest has white stained glass.
Mhm.
But also it has in different other slots that I do not remember where they are, but I'm sure there is another
Mhm.
one at least. I don't know why it's not here actually. Oh, I know why. Yeah, never mind. It's because it's the first hole and the first hole is 000.
Okay.
So we have 6 slices, right?
Mhm.
Not 6 slices, 6 holes. Well, in this case 3, but each one has like left and right. So left from the first hole is 000, but then the right part of the first hole is 001, and then the second hole left is like different things.
Mhm.
So yeah. So as you can see, we have white stained glass in 2 different spots. And what will happen is that the minecart will just go over it, under it, sorry, and it will pick one slot of stained glass. And if you check this comparator here, it's giving
Yep.
signal strength 2,
Yep.
which means that it's selecting this
Triggering
torch,
this.
and
Yep.
it's yeah. So whenever you pick an item, any item type, it will just go to 0, which means this is going to trigger. So
Mhm.
what happens is that since this changes from 2 to 1, this observer detects it and
Mhm.
sends a signal to this red line.
Mhm.
And as you can see, there is another truth table here. And yeah,
Mhm.
that's another type of encoding.
Yep.
So we just convert item types into code. That's the whole purpose of an encoder. And then there is another serial transmitter here, the same thing that we explained before,
Mhm.
and that sends the code to unlock the slice in the hole, in the bulk. So I guess I can quickly sense something there, so we
Okay.
can see how it's working. So it's going to be really fast.
Yep.
So
Probably hard to follow. Yeah.
yeah,
Just getting shot through the dropper lines there and put into the corresponding slice in the bulk storage. Okay, let's maybe do that. We should get a signal.
okay. So I'm going to send one birch log. Okay.
Okay. Chest of logs.
So the birch log, so you can see real quick where is it? Is in bulk. Is the third hole,
Yep.
and in the third hole is in the fourth slice.
Okay.
So you can probably see
This
that
one
there
here.
are some. Okay, so if you check
Okay.
the
Yep.
dropper, it has birch.
Okay.
Okay, I guess we can quickly see that. Anyway, I'm going to input birch
Okay.
right now. So it's going to take a while because it needs to
Mhm.
select. But then what is going to happen is the box is going to be sent into the encoder. Just wait for it. And then we will see how it selects the actual slice.
Yeah, waiting for the signal here. Yep, there it
And
is.
now, there we go.
Okay, selected slice.
It should. Here we go.
See, we should have a second one in there.
And now,
The dropper? No.
let me wait. Now it's getting sent, and now it just needs to wait a bit.
Maybe it's to trickle a bit through all the hoppers.
Yeah.
Yep. There we go.
There we go.
Yep.
So we just encoded that item.
Mm-hmm. And it's
So
also
that's-
gonna be like fully expandable in case we want like new items also be stored in bulk. Can we also like resize? So there's like this one item, as it turns out, we actually need a lot of it because we found a new application with it. Can we also reassign it to a bulk storage?
Yes.
Okay.
So if you go to the first hole right here, right, there is a glass that is not really doing anything here.
Mm-hmm.
So
Okay.
why is this like this? So we have from the glass to here, we have slots that we are not using, and we can use that for any code that we want.
Okay.
So you just need to give it a code. So if you go down here, you can see there is another truth table in right, but this one is all 0. So drop observers means 0, concrete means 1. So imagine that, for example, we want 3 million of cobble instead of 1 million. So what will happen is that we will select the same code as cobble and we will repeat it twice.
Okay.
So that way we can have 3 million of cobble there.
Ah, yeah.
That's how it works.
Okay. Then hopefully, in case this is still working 120 and there will be new items, we can also then expand it. But who knows? I mean, the 119 snapshots, they, for example, changed the rail update order, which would have completely broken this and stuff like that. So we have to see if this is gonna work in the new versions. It would be a lot of work to recreate or fix. Hopefully, merging won't screw us over here.
Yep.
Okay.
Okay. So now I'm going to quickly explain how the player call works because I think it's the most important one.
Yep.
So we are also going to. So what I'm gonna do is I'm going to use this thing here. This is the player call. So this is a UI made by Optic. So if you check the box right now, it has 1 furnace and 2 planks.
Yep.
So each item that I input here, each like not item type, each item means 27 boxes. So right now I'm going to try to call for 20 boxes of furnaces and 20, in this case, 20 boxes. Sorry, not 20 boxes, 27 boxes.
27.
27 boxes multiplied by 2 because I input 2 veg planks. So that means that we should get 27 boxes of furnaces and 54 boxes of planks.
Yep.
Now, I'm going to do something here, and that's like why I place furnaces. We don't have furnaces in bulk. Okay? So that means that the system is going to tell me that we don't have furnaces in bulk. So that's why we have the orders complete and the orders failed. Orders failed means that we don't have anything, like we either don't have anything in bulk or we don't have it encoded. And
what if we don't have enough? We only have 26 shulker boxes.
It will still say complete because you call for it.
Okay.
So what will happen here, and let's quickly explain. is that when we trigger this, and I guess we can quickly explain what this thing here is.
One sec.
Is
Okay.
so this thing here is basically the brain of the whole storage.
Mm-hmm.
So this is a priority list. As you can see, it says player, encoder, and whole.
Mm-hmm.
So right now we only have those three. We can add more things, but we only have those things. This
Mhm.
is a priority list, and what this thing makes is that it makes sure that only one thing is working at a time.
Mhm.
And different thing has priority. So as you can see, the player has priority over the encoder and the whole.
Oh, almost
So
like
that
a
means,
computer.
yeah. So that means that if the whole is selected and the player is selected, the whole will not start until the player is finished. Okay.
Yep.
So what this thing, what are we going to do is that we are going to pull this thing down and then up again, but that's going to move this thing upwards. So the normal state of this target block is down, but when we select it, it will go up, right?
Mhm.
And it will stay up until the whole process is finished. When it's finished, it will go down. And if anything else here is selected, for example, the encoder, then the encoder will go up and the target will go up again until the encoder is finished. And then imagine that player it happens again, so the player will go next. So what will happen here is that we are going to send a box, right? And the box is going to get stored here in this hopper. So whenever this hopper gets selected, as you can see, we send a signal through here, which is going to activate the priority list, the brain. And then the brain, if there is nothing else, we send a signal back here, which will basically trigger the dropper and will send the box to the encoder. Now, also there is another thing that happens, and then there is this thing here. This is another latch, this piston. This will activate too if the player gets activated. And what happens basically is that this piston, this water string gets rerouted. So normally everything that the encoder makes gets sent into this water string, and this water string goes directly to bulk. But however, we will trigger this, which all it's going to do is just going to basically take one item, and if there are more items in the box, it will just repeat the process. So as I said, I input 3 items, so it's going to repeat the process 3 times. What we do is that we also have another latch here. And this latch, what it does is that there is a fatal clock here. It will try to call. So there are the calling and the sending, right? So we just call here. So what I'm gonna do now is I'm going to trigger the button, and you're going to see how the box is going to get placed in this spot in the encoder. And it's going to take one item out and place in the hopper. Whatever item takes out, right? It's going to call for it.
Okay.
So let's quickly check. We're going to press a button.
All right.
There we go. As you can see, the box gets placed there. The encoder works. And now we are sending it to the encoder. And I can quickly tell you what we are gonna do. Okay, so we are calling for furnaces. But as I said, there are no furnaces in the encoder, right? So what's going to happen is that this fatal clock is going to try to do something.
Yep.
But it's not gonna find anything. So since it will not find anything, what's going to happen is that bulk is going to say we don't have that. And since we don't have that, what will happen is that this piston here will not get pushed.
Okay.
So that means that an item is going to come here and it's going to say order failed.
Okay.
So the item comes there right now. There we go. And as you can see, it says orders failed. But right now we are encoding for Verge right now.
Yep.
As you can see, the encoder is working. We send the signal to bulk. Now you can quickly come here to the fourth slice. And you will see in this dropper how it's going to activate. So it got selected right now. And it's going to call any moment now. There we go. So this is an AND gate with tile tick priority.
Mm-hmm.
And right now we are sending all of those boxes through this dropper line, and it gets sent back into this chest. So if we check this chest, we have 27 boxes. However, I send 2 items, right? So what will happen is that it's going to try to encode again.
Yep.
And as you can see that the order is complete, it will say any moment now that we got an item. There we go. Order is complete. And now we got a barrel. Bird, sorry. But now it's going to do it again. So the encoder is working right now. And we are going to repeat the process. So we are going to call for 54 boxes. So we wait like another 10 seconds or 15 seconds, and we will get...
Do you know... I mean, we could have measured it, but how long does it take to get the planks?
Well, there is a lot of things that need to happen. We could try to make it faster, but we just made it how it worked. And it's already fast enough, so it's like...
It's like a minute, seconds. Right?
It takes a bit less than that. Calling is a lot slower. But as you can see, we are calling for more.
Okay.
So there we have the 54 boxes that we called. And now, since the box is going to be empty down here, there we go. The box is instead going to be sent into this water stream. And that water stream just is going to wait for here. So it's going to say another order complete of planks. And the box will get placed here. There we go. So as we successfully called for that.
Alright, so this is how our state-of-the-art storage system works. There's even more that could be explained. For example, what happens exactly if our storage slices here don't have any shulker boxes left anymore and new ones are requested from the bulk storage. So Jorge explained it to me in detail as well, but I found the explanation a bit hard to follow and also took about 30 minutes, so I decided to not have this in the video. But in case you're interested in that kind of stuff, Jorge plans to do an even more detailed explanation of the storage system on his YouTube channel, so you can check that out. Alright, so as I said, last episode of Season 1. It's kind of hard to make a clear cut between like seasons because we're not starting a new world. But there's definitely a huge change now in the setting because we moved out over 100,000 blocks away from spawn and just want to start over because a lot of the old infrastructure is just outdated. It would be hard to fix stuff because pretty much most of it is broken. There's so much new terrain and things they got added in all those versions, so we kind of wanted to start over. It's not going to be a hard cut in terms of the things we have, so we don't want to use the old items anymore, rely on the ones we farm here. But for example, we're just going to keep our tools and so on, and stuff we have in the ender chest, so we can cut out like the first day of playing the game. I mean, it's be kind of silly now to start over with wood tools and do all of that grind again. So we're just gonna start with our netherite gear, also our god leggings, of course. So not a complete hard cut, but definitely a restart type of thing we have going on. I'm also not sure about how we should do the episode numbers. So we got 174 now. I feel like it would be appropriate to start over with SciCraft Season 2, Episode 1 for the next one. But not entirely decided on it. Also gonna read the comments, what you guys think about this. Alright, so then thanks guys for watching all this time. 174 episodes. Hopefully we're gonna get 174 more with Season 2. And thanks so much. See you next time. Bye bye.